Bitcoin is the most secure blockchain in the whole Web3 ecosystem. So the idea of sharing the security of Bitcoin with other blockchains is actually not a new idea. In fact, Satoshi Nakamoto, the inventor of Bitcoin, came up with this idea called merge mining in 2010. The merge mining idea was to share security between Bitcoin and another proof of work chain.
Hello, and welcome to Public Key. This is your host, Ian Andrews. Bitcoin is back, baby. Well, at least that's what our next guest, Stanford professor and co-founder of BabylonChain, David C., is telling us. David and his team are exploring how Bitcoin can be used to secure proof-of-stake networks without the use of bridges by using Bitcoin's native time lock feature and cryptographic methods. That sounds pretty complex, but it could be amazingly powerful. In the episode, David discusses his love for Bitcoin, and while many new startups are moving away from the network to chase the programmability of smart contracts, you only have to look at the price of Bitcoin to see its value. We dive into the technology behind BabylonChain as they prepare to launch their mainnet, and David highlights the reinvigorated investor interest in Bitcoin, powered by recent ETF approvals and L2 projects. Now, one thing before we jump into the episode, a little crypto trivia for you. What do India, Nigeria, Ukraine, and Brazil all have in common? Well, they're featured in the top 10 of our 2024 Global Crypto Adoption Index. Yep, it's that time of year when we take our original research powered by rich data and break down crypto usage around the world and the effect policy and regulatory frameworks has on those regions. To get a preview of the report, you can visit our blog by clicking the link in the show notes. And while you're there, you can sign up to get a full copy of the report as soon as it's published. Today, I'm joined by David C., who's co-founder of BabylonChain and also a professor at Stanford University. David, welcome to the program.
Hey Ian, very nice meeting you, and thanks for having me here.
David, it is my pleasure to have someone with your storied career in research. We'll come to that in a moment, but maybe we can start with BabylonChain. I was introduced by a former colleague, sent me the white paper a few weeks back, and I have to say this idea of being able to use Bitcoin to power proof-of-stake networks was a little bit mind-bending at first. Can we talk about maybe a quick overview of the concept? We'll dive into the details as we go into the show, but a quick overview of the concept and where the idea came from that led you to build Babylon.
You know, Bitcoin is the most secure blockchain in the whole Web3 ecosystem. So the idea of sharing the security of Bitcoin with other blockchains is actually not a new idea. In fact, Satoshi Nakamoto, the inventor of Bitcoin, came up with this idea called merge mining in 2010 timeframe, when he was still around. The merge mining idea was to share security between Bitcoin and another proof of work chain. So as everyone knows, Bitcoin is a proof of work chain. And so Satoshi Nakamoto have this idea of sharing the work that is done by the miners with another proof of work chain as the means of sharing security. What we came up with is this idea that, hey, you know, new blockchains that are coming up in the past 5 years, they're almost all proof of stake. So therefore, this mining concept is not very useful for those proof of stake chains. You get security from Bitcoin, okay? Then we came to the observation that although Bitcoin is a proof of work chain, that proof of work is securing an asset which is worth today about $1.2, $1.3 trillion. So that asset itself could be a staking asset to secure all these proof of stake. So that was sort of a eureka moment, okay? Instead of thinking along the lines of Satoshi Nakamoto focusing on the work, we focus on the fruit of the work, which is the Bitcoin asset itself, and use that to secure the proof of stake chain. Now, this concept is actually quite loaded because most proof of stake chains are actually, the current ones, are actually secured by their own asset. And what we're saying here is a broader point, which is actually you don't need necessarily your own asset or only your own asset to secure your chain. You can bring in a much bigger asset, and that asset can provide collateral to ensure good behavior and to secure your chain. And so what we're saying is that that big asset, a natural one, will be Bitcoin. And so our protocol at a high level enables Bitcoin holders, any Bitcoin holders, to stake their Bitcoin and to use it to secure a proof of stake chain when our protocol is fully built out.
I've got so many questions about how this works in practice, which we'll dive into. But I was going through some of your research that you've published on Google Scholar, and I noticed that there's quite a bit of research being done into mechanisms of compromise or potential weak points in the Ethereum chain architecture and other networks as well. What led you to that particular vein of research, and does that relate to eventual development of BabylonChain? Like a better way to secure some of these networks seems connected in my mind.
Yeah, so maybe a broader context of my background is that I entered the crypto space 5 years ago. I'm primarily a researcher. In my past life, I've been doing a lot of research on wireless infrastructure. So I started doing that almost decades ago. So a lot of the technology that you use on your cell phone is actually, some of them are due to my invention. But 5 years ago, I decided that this blockchain area is really a super cool research area. So I started a research group at Stanford to do research in this area. Now, actually, our beginning research point was how to scale up Bitcoin, how to design a better protocol to scale Bitcoin. That was our first paper in the area, actually. After we wrote that paper, we thought, whoa, we hit it big, okay? Guys, we solved the problem, we scaled Bitcoin, what else is there to solve? And then we realized that the rest of the world went a different direction. The rest of the world went to the proof of stake direction.
Yeah.
And we were kind of obsessed about Bitcoin because that's how we entered the space.
I'm curious if you recall, what were the recommendations to scale Bitcoin in that first research paper that you produced?
So Bitcoin is very slow because every block, okay, is produced once every 10 minutes. And so you think of a blockchain as like a voting mechanism, then it's as though you're saying we're gating. We only allow one voter to come into the voting booth every 10 minutes. Imagine now, in a country like United States, how long would that take to elect the president? One voter every 10 minutes. And that's why Bitcoin is so slow. You only have one voter every 10 minutes.
Yep.
So we figure a way to kind of parallelize Bitcoin to many, many parallel chains, so that many people can simultaneously vote on a Bitcoin block, so that you can finalize it, you can confirm it very fast. So that was the innovation. That was the main innovation.
Okay, and so back to the story. So that wasn't picked up. The world said, hey, instead of taking that approach, we're heading off down the proof of stake. And so what did that mean for your next research effort?
So we should probably do some research on proof of stake, because nobody cares about proof of work anymore, it seems. Okay. All right. So the first paper, one of the early papers we looked at, was a paper by Vitalik. Okay. So at that time, it was around 2020. COVID was hitting us, and we had nothing to do with sitting around. But then Vitalik published a paper on a protocol called GASPA. And that was the protocol for Ethereum proof of stake. So that was still 1 year before the merge. 1 year before the merge. He published this paper to get sort of the community input on the proof of stake Ethereum based on this protocol. Well, lo and behold, me and my students find a few attacks on this protocol. It's not secure. So we go and contact Vitalik, and we realize that he was actually trying to fix the protocol. He was trying to fix the protocol. After 6 months, we came up with even more attacks. And then he realized that maybe it's not a good idea for him to go and not communicate with us and just fix the protocol by himself. And so we started a 1 year long collaboration on how to improve the Ethereum proof of stake protocol. In that process though, since we engaged with the Ethereum Foundation very closely, Vitalik and his team, we learned a lot about how to build good proof of stake protocol, and also the security vulnerability of proof of stake protocol. Babylon project is kind of like a combination of our first love, which is Bitcoin, and our understanding of the limitation and the advantages of proof of stake protocols, and sort of marry the two together to build better and more secure protocols.
Amazing. What were some of the vulnerabilities in the protocol that you discovered in your work with Vitalik?
So there are two vulnerabilities that we discovered. One is that in a proof of stake protocol, typically you want to, it goes back to the theme of this idea of Bitcoin is very slow. Proof of stake protocol tries to be fast. You want to confirm like a few seconds. And to confirm fast, you have to have a lot of people voting. But if you design a protocol incorrectly, then when you have a lot of people voting, it is easy to have a deadlock. Because half the people think we should go this way, the other half thinks you should go that way, and now you're stuck. The protocol is not moving forward. And the attacks we find are basically these kind of attacks where we can stall the Ethereum protocol. And this attack does not happen in Bitcoin precisely because you only have one vote every 10 minutes. Yeah. And so therefore this stalling is very hard to do because the voting is so slow.
That is fascinating. So now maybe diving into BabylonChain a little bit. I think most people listening to this podcast familiar at least with the basic idea that, the Ethereum network, when we talk about staking, there's network staking where you're depositing 32 ETH to actually operate a validator node. And that in turn secures the network. You have people who have a financial incentive to not produce illegitimate blocks on the chain because it will risk their deposited assets. They're kind of held in the validator node. So when we talk about being able to support proof of stake with a non-native asset like Bitcoin, the first question that came to my mind was, well, how do I get Bitcoin from the Bitcoin network over onto this other network so that I can deposit into a node for a validator? But I think you've proposed a different style of architecture here.
So, people's mind, they try to fit into an existing model. The existing model is that the ETH is sitting on the Ethereum and they're providing secure Ethereum. So now I want Bitcoin to secure Ethereum or secure any proof of stake chain. So the natural idea would be to move the Bitcoin onto Ethereum in order to provide a security. But the moving of the Bitcoin is through a technology called bridge. Okay, this would be a Bitcoin bridge. Now, once you bridge to Bitcoin holders, then you lose like 95% of the people already.
Yeah.
Bitcoin holders do not want to bridge. And that's one reason why Bitcoin, the asset, is kind of have a very low utilization. Because there's nothing much happening on Bitcoin. People don't want to move the Bitcoin to other chains. So they're kind of stuck. And they say, okay, it's fine. We'll just wait for the Bitcoin value to keep on going up. People, when you ask them what do you do with Bitcoin, they say it's just in my wallet and my cold wallet. So solution, when we think about this problem, we don't want to bridge the Bitcoin. So the Bitcoin actually remains to be on the Bitcoin chain. Now, to achieve that, we need to have two properties for the Bitcoin. So we are kind of thinking about the staking process at a more abstract level than the mechanics of where to put the Bitcoin, who to validate, who to hold that Bitcoin, right? At a high level, what do you want, right? At a high level, what we want is two things. One is that the staker should need to lock the Bitcoin or lock the stake so that they can't take it out arbitrarily. And that locking mechanism provides the security, number one. Number two is that asset should be a true collateral in a sense that if the validator that the staking is supporting is doing bad behavior, that fraction of that Bitcoin should be sent to, say, some burn address to punish the staker, and that provides the collateralization of the security, okay? So those are the two abstract properties. So we found that we can achieve properties by keeping the Bitcoin on the Bitcoin chain, okay? The first property is through a Bitcoin opcode called time lock. So in Bitcoin, you can lock your Bitcoin. So if you're bored, you can actually lock your Bitcoin for 1 year, and then only after 1 year, you can take the money out. No one else can take it in the meantime, though. So you can use this lock to implement the first objective. Okay.
And that lock is natively part of the Bitcoin.
Yes, it's natively
protocol.
part of Bitcoin.
It's nothing that Babylon's had to implement or introduce. Yeah. You're just leveraging a feature that's always been.
Yeah, so a little bit technical jargon in the Bitcoin world called Bitcoin scripting language. It's like a smart contract language analog from Ethereum. Now, in this scripting language, there are certain opcodes, operation codes, that allows people to program in an efficient manner. And one of the opcode is this notion of a time lock. So if you use this opcode, it will be locked for a certain amount and we release only after this amount of time. So this is already there in the Bitcoin scripting language. However, the challenge is actually not the time lock, which Bitcoin has, but how do you achieve this collateralization property, this slashing? Because this property on the proof of stake chain, which is the outside world, and we need to reflect what happens in the outside world, what happens on the Bitcoin proof of work chain, which is to slash the Bitcoin. And that is the core of our innovation to do that. And we do that in cryptography to turn this bad event signal from the proof of stake chain into something that leads to a spending of a fraction. So that is kind of the secret. It's not a secret, but it's the magical source of our technology.
And yeah, this leads me to my next question. So you've got this financial incentive. I want to be able to take my Bitcoin and do something with it. So presumably by supplying it to secure another network, I'm going to earn some reward, similar to how people staking on Ethereum earn staking rewards. You also want to have a financial penalty for people who are not operating honestly, so trying to produce a fake block, or perhaps just operating casually, like they don't respond to block creation requests or to validation requests effectively. You want to be able to take some or all of the financial asset that they've locked into the chain from them. So you've got this incentive penalty structure laid out. I, as a user with Bitcoin on the Bitcoin network, can then use Babylon to kind of enter into this contract where my assets are time locked. So I'm committing to a particular period of time the assets available. How, though, am I doing validations of blocks being created on another network? Is there a piece of infrastructure that I have to run as a user? Do I end up running a validator node on one of these other networks?
Yeah, so that's a great question, Ian. Let me break down the answers to a few things. First, the issue about that the two networks here. One is the Bitcoin network, and the other is the proof of stake network. So let's understand why there are two networks. Now, in normal proof of stake protocols, there's only one network, proof of stake chain. The validators are running on the chain, and the ledger that maintains the asset that provides the staking is also on the same chain. So everything is within one chain. Now, in our protocol, the Babylon protocol, there are two chains involved. One, the proof of stake chain, which needs a security, and two, the Bitcoin chain, which maintains the ledger of the Bitcoin. So that's why the protocol has two chains, and therefore the protocol is actually an example of a so-called cross-chain protocol. That is a protocol that allows two chains to communicate with each other. In this case, basically the validators, what we call finality providers, is actually being run on the proof of stake chain. But whenever there is some bad event that is happening, a message will be sent back to the Bitcoin chain to create this slashing, this penalty that you mentioned. Now, so that is basically how the protocol works in terms of having multiple chains. So I think the cross-chain is a very important concept that should be emphasized here. This is number one. Number two, in terms of whether the staker has to actually run their own node on the proof of stake chain. Now, if you go back to the general proof of stake concept, actually, even in general proof of stake networks, there are two types of staking. One, maybe you can call it direct staking or direct validation, is that the staker runs their own node. For example, in Ethereum, if you have 32 ETH, you can run your own node, okay? However, there's another type of proof of staking, which is so-called delegated proof of stake. That is, a staker provides the capital, delegates that capital to a professional node runner to execute and to validate. That is, in some sense, a more common form of proof of stake. Not to mention that the first one is also happens, but the second one is actually more common. Now, the Babylon protocol allows both. Okay, so as a capital provider, for example, you may be from a big institution. You want to run your own infrastructure, so you can provide capital and run your own node. Perfectly okay, and we have partners that are doing exactly that. Number one. Number two is that if you are a relatively small capital provider, you can delegate it to one of the professional validators of the world, like Figment or P2P or BlockDemon or some other professional validators, and then they can validate the proof of stake chain using your capital as the collateral that provides the security.
Yeah, this is fascinating. So much like in the world of Ethereum, where many people don't actually operate their own node, they delegate. You have the same delegator architecture here.
An example is Galaxy Digital. So actually we have a test net already, the Babylon test. Galaxy Digital is running a node, and they also have the capital, they have Bitcoin, because Galaxy Digital is actually also a Bitcoin miner. They got this Bitcoin from Block Reward, and they do self-delegation to their own validator. It's so-called delegation mode.
Yeah. Explain what is actually the architecture of BabylonChain then, and where do those interactions between both the Bitcoin network and off to a network that's using the staked Bitcoin in order to secure itself, like how do those happen? Can you describe what BabylonChain actually is? How does the BabylonChain ultimately interface to another network that it's securing in order to provide that security? Like, what is the mechanism of communication and how do those interactions occur?
Okay, so before I go into the details, let me start from clarifying two different concepts here. One is the Babylon Bitcoin staking protocol, which is this protocol that allows Bitcoin holders to supply capital to secure any proof of stake chain. So this is the overall protocol that we are building and we are launching. Now, in addition to the core, as a core piece of infrastructure of this protocol, there's the Babylon chain that you mentioned. And the reason why there's this chain, which is a core part of the protocol, but not the whole protocol itself, is that, as I mentioned, our protocol is a cross-chain protocol. It is a cross-chain between the Bitcoin chain, where the security comes from, and the proof of stake chain, which is consuming that security. Now, as you know, a lot of cross-chain protocols like, layer 0 or so-called IBC communication requires a notion of connectivity between the two chains. And this is where the Babylon chain comes in. The Babylon chain is kind of like an aggregation layer that allows many proof of stake chains to communicate with Bitcoin. So in theory, one can build a protocol where each of these chains will attempt to directly communicate with Bitcoin. But as you know, Bitcoin has a very small block space. And if every chain does that, then the protocol overall is not very scalable. And we run into huge congestion problems, like, that when the OR nodes peak time, a lot of congestion, that kind of congestion may happen. So you can think of the Babylon chain is kind of an efficient aggregator to help all these chains to communicate with Bitcoin. Now, there is actually a blockchain called Axelar, Axelar, that maybe some audience have heard of, also perform a kind of a similar in spirit role, which is the aggregation to help with many chains communicate with each other. And in some sense, the Babylon chain plays the similar role in the context of the Bitcoin staking protocol. Axelar is a general messaging protocol, but Babylon chain is a specific one that helps all these chains to integrate with Bitcoin easier.
Thank you. That clarifies a misunderstanding that I had for sure. So the Bitcoin staking protocol actually runs entirely on the network using the Bitcoin scripting layer.
Correct.
BabylonChain today is almost a proof of concept implementation so that you can go demonstrate to other chains, look how you can use Bitcoin to secure a proof of stake network. Got it. That's really fascinating. So what has been the reception since you've launched? I think right now you're kind of in the testnet phase of availability. Are people clamoring for the opportunity to start using Bitcoin to secure other networks?
When we launched our testnet, we had to encourage people to stake on our testnet, and 100,000 people stick in the first 2 days.
Wow.
We know because we have an NFT campaign where the first 100,000 stakers can claim an NFT. So I think there's a lot of interest from the supply side. Now from the demand side, which is the blockchain, there we have a project. And one particular area that received a lot of interest is this so-called Bitcoin L2. So Bitcoin is undergoing a certain revival. With the Bitcoin ETF, there's a renewed interest. When we started doing research 5 years ago, people thought we were kind of stupid working on Bitcoin because everyone moved on. Hey, but you know what happened was that Bitcoin is back.
Yeah.
And there are a lot of new projects building on Bitcoin. And so we become like a go-to marketplace for all these new projects to get security, Bitcoin staking. And so we receive a lot of attention there. On the other side, we have a collaboration with the Cosmos Hub, which is the main Cosmos chain. And they want to share the security of Bitcoin so that they also use that to secure other Cosmos chains. And so I think there are a lot of, in fact, we are really limited right now in terms of team members. So by the way, anyone listening to this, if they're interested in participating in Babylon, come and talk to me.
Yeah, that's exciting. It's nice to hear people having the "we're hiring" advertisement on this program again. It had slowed down there for a little while. So anybody out there looking for a new role in Web3, it's sounds like BabylonChain needs engineers. One of the projects, I saw a press release from a few weeks back where you'd partnered with Nubit to support their technology layer. And I gather that Nubit is a data availability layer, so related to some of the NFT ordinal type work on Bitcoin. Can you talk a bit more about what that integration actually enables?
So Nubit is a new project that is building on Bitcoin, and basically Bitcoin itself, the block space is very limited. So now imagine you want to build new projects and new applications on top of Bitcoin. If you are using that space, get extremely crowded. And so Nubit builds a so-called data availability layer where projects can use Bitcoin asset, but at the same time use Nubit to store data onto the Bitcoin chain directly. So that Nubit is so-called data availability layer. Now, this is part of this whole idea of so-called modular design of consensus protocol, where you separate out different funds for different projects to do. Now, data availability layer itself needs security. Every essentially modular component needs security. Otherwise, people who are doing data availability will do weird things. And the Babylon integration is that the Babylon will take Bitcoin staking to secure the Nubit data availability layer. Now, I was just saying that this is a good example of a naturally used staking as a security mechanism.
Now, you're still in the testnet phase right now. What's the plan to get from here to mainnet? When should we expect to see this start being available in production?
Yeah, so the testnet has the dog food chain, BabylonChain. It has the Bitcoin scripting, staking. So it's a full system. Now we want to move this to the net. So mainnet means what? Mainnet means real Bitcoin. Now, real Bitcoin and test Bitcoin is quite different. Real Bitcoin is gold and test Bitcoin is like, I guess this is we should know
dirt.
Language, yes.
Yeah.
Whenever we have real Bitcoin, we have to be very careful. So therefore, we decided to launch the mainnet in 2 phases. So in the first phase, we take only the scripting part, the staking part, and launch it as mainnet. Bitcoin holders can come in and they'll stake the Bitcoin and they'll log through our contract. This phase 1. This phase 1 will be around a short time, maybe 3 months. And then once we get people used to locking real Bitcoin into this contract, then we'll launch the BabylonChain, and then the validators will start validating.
So we're talking before the end of the year, we should have both phases live, it sounds like, from what...
Yeah, so mainnet phase 1, we're shooting for June right now. We're shooting for June right now for mainnet phase 1. Okay. We're having 4 security auditors look at this code in different ways. Some white hat, some gray box analysis, some code by line by analysis. Very important because we don't want to lose people's Bitcoin. So this will be done probably near the May timeframe, second half of May time, and then we'll launch in June, the mainnet phase.
That's exciting. A question that just occurred to me is, so once I've locked my Bitcoin, I'm now earning rewards. What are the rewards paid in? What asset do I actually get rewarded with?
So it depends on now the chain that you secure. So in the BabylonChain, so let's think about Bitcoin staking to secure or to improve the security of the Cosmos Hub. Now the Cosmos Hub have a native token already called Atom. And every year they're inflating Atom by about 10%. That's the inflation rate of Atom. And most of that 10% goes to the Atom stakers right now. So when we have Bitcoin staking integrated with them in production, then the proposal right now is 1% of this 10%. So 1 versus 9. The 1% of the Atom inflation will go and reward the Bitcoin stakers. The reward will come in terms of Atom tokens.
Got it.
A different application though. For example, you may have a chain running a stable coin. Then the reward could be different in terms of the stable coin itself. So the reward you get very much on the application and the economy that you're securing on that chain.
And how does one choose which application or ecosystem they're staking? When I enter into that locking contract, am I making a conscious decision, or does this happen kind of automatically where my assets are just distributed across anywhere there's demand for security?
So you are typically delegating to a validator. Okay, and the validator will be securing certain number of chains. And so in some sense, you're picking the chain and picking the validator that you like to secure. I want to secure the Cosmos Hub, and I want to use the Figment validator, for example.
So you have to know a bit about the ecosystem that you're planning to support, right? Because you could have potentially an asset that's not really worth anything. Has no exchangeable value, I guess I could say.
Yes.
Which may be less economically interesting to somebody looking to earn an interest return on the staked asset, if I'm following correct. You need to do some research, it sounds like.
Yeah, it could be a blue chip token like Atom, which people are familiar with. Or it could be a new and hottest project. Want to get reward in the new token because you think that token is going to be valuable.
And is the project open source, or if someone wants to adopt support for this, like what is the process? If I'm building a new project, I listen to the podcast and I say, wow, this sounds great. How does one go about getting started?
Yeah, I mean, eventually you want it to be complete open source and then where they can integrate this. But right now we are kind of working with projects to help them to do the integration. So I think the first step is probably approach us. The code is open source, yes.
Amazing. And what's the best way to get in touch with you or the broader team? Just BabylonChain.io?
You can also send us a contact message through the BabylonChain.io website.
Amazing. David, this has been a fantastic conversation. My last question, what are you excited about as you look across the ecosystem? You're so deep into this entire world. What should we be paying attention to over the rest of 2024?
2024 is, I think, the year of Bitcoin. Bitcoin's back. So we see a lot of interesting new projects building on Bitcoin right now. And there's still a huge number of projects. So I think there'll be a lot of excitement about new protocols on Bitcoin, perhaps even some upgrade on the Bitcoin chain to enable even more new building of Bitcoin. So I think there'll be a lot of activities around Bitcoin.
Amazing. Well, David, thanks so much for joining us on Public Key. This has been fun.
Very nice being here. Yeah.
Hey there. Thanks for listening to another episode. If you enjoyed what you heard today, do me a favor. Open up your podcast app, rate the show, give us a review, tell us what you liked. Even better, you can share the podcast with your friends. And of course, make sure you subscribe so you don't miss the next episode. Wow, this episode was packed full of technical references. And if you feel like you need to brush up on your crypto basics, I certainly don't blame you. That's why our team has created a timely blog about zero knowledge and optimistic rollups. As David referenced in the podcast, the scalability of blockchains has historically been a significant challenge when designing and building decentralized applications to support growing user bases. Our team's compiled research about what rollups are, how they work, along with the benefits and challenges of both of these technologies. They even give a side-by-side comparison and include a discussion as to why optimistic rollups are faster and easier to develop and more compatible with Ethereum. Head down to the show notes and arm yourself with more crypto knowledge.